Hello everyone. So today we move on to the next chapter, which is relations and functions. This is actually the first chapter in your textbook of mathematics for class 12 and in part 1. Now in examination point of view, if you look at, you can expect 2 mark, 4 mark and even a 6 mark question from this chapter. Now since we have this objective type questions, we can expect the questions in objective type 2. So, as the name of this chapter suggests, it is relations and functions. So, first part deals with relations. So, in order to understand relations, we need something as a prerequisite. That is something which we have already studied in your class 11 from the chapter sets. So, let's have a quick look into that, some concepts which we require to understand relation in its fullest. So, what was a set? Can anyone recall what was a set? Yes, what is a set? A set is a well-defined collection of objects. Yes, I repeat, a set is a well-defined collection of objects. So, these objects means it can be numbers, it can be functions, etc. Well, I am going to introduce 2 sets here. So, set A is given as set 1, 2, 3 and set B, I write it as 4, 5. So, these are the 2 sets. Now, what is the Cartesian product from A to B? I repeat, what is the Cartesian product? It's also called as the cross product. So, A cross B, that is the Cartesian product from A to B. What is that? It is the set of all ordered pairs that can be formed by taking the first element from set A and the second element of the ordered pair from set B. So, what is the first element from set A? 1. First element from set B? 4. That comes as the second one as in the ordered pair. Second element in the ordered pair comes from set B. So 1, 4. Then what do you have? 1, 5. Then 2, 4, 2, 5. Then what do you have? 3, 4. And then finally we have 3, 5. These are the all possible ordered pairs that can be formed by taking the first element of the ordered pair so formed from the set A and the second element from set B. I hope this is clear to you. Or in set builder form, I can even write it as set of all xy's, ordered pair xy, such that x belongs to set A and y belongs to set B. So this is the set builder form for A cross B or the Cartesian product from set A to set B. I hope it is clear. Now, what is a relation? What is a relation? I define relation from A to B. I am going to define a relation from A to B. How do I notate it? R is a relation from A to B. This is how I notate it. Okay. So, R is a relation from A to B. Now, how is this relation defined? Now, I am going to define it as the ordered pair. The ordered pairs with the first element. The first element as odd numbers. As the first element as odd numbers. So, what am I going to do here? I am going to apply this relation in this A cross B or in this Cartesian product. So, when I introduce this relation into this, what will I get? I am going to filter down certain ordered pairs that satisfies this relation, isn't it? So, when I filter it down based on this given relation, what do I get? It gives me another set where the first element of the ordered pair is the odd number 1, 4. Then, which is the next one? 1, 5. Which is the next one? 3, 4. And then finally we have 3, 5 also. Now look at all the ordered pairs that I have taken from the Cartesian product under this particular relation is having the first element in the ordered pair as odd numbers. Am I clear? Now, one more thing you have to see here. What is that? This relation, what I have got here, is a subset of the Cartesian product. This relation is a subset of A cross B. So, finally, I can say that a relation is always a subset of A cross B. Understood, children? So, this is the first part. First thing what you have to understand from sets. Okay, have a quick look. So, let's have an example. Here, I have two sets. Set A, 1, 2, 3 and 5. Set B, 4, 6 and 9. Now, R is a relation from A to B. Given R is equal to set of ordered pair xy such that the difference between x and y are odd, an odd number, and x belongs to set A and y belongs to set B. Now, what is this form? In which form did I write this? I have written it in the set builder form. You are familiar to this. This is written in the set builder form. To understand what are the elements that is going to come in this relation from our previous Cartesian product. I hope you remember. Yes. So, I am going to apply this relation and find out what are the elements that is formed inside the given relation. So, in order to get that, I am writing it in the roster form. So, in the roster form, when I write it, I have R is equal to set of ordered pair that satisfying this relation, isn't it? The first element is from set A and the second element is from set B such that their differences gives you what? An odd number. So, first element 1, second element 4. The difference is a odd number. So, you have 1, 4 in this relation. Then, what about 1, 6? It also gives you a odd number. 1, 9. It is not an odd number. So, we don't have that in the relation. 2, 4. Again an even number. 2, 6. Again an even number. 2, 9. It definitely comes under the relation. Satisfies the relation. Then, what about 3, 4? Definitely you have 3, 4 also in the relation. 3, 5. 3, 6. 3, 6. It is a odd number. So, you have 3, 6 in the relation. 3, 9. It won't be there in the relation. 5, 4 definitely falls for this particular relation. Then 5, 6 yet another element in this relation. And what about 5, 9? It won't be there in the relation. So these are the ordered pairs that satisfies the given relation. Now, what is the domain? How did we define the domain when we studied the sets? Hope you remember that. That is, they are the first number, the first element in the ordered pair. From these ordered pair, you take the first element. So, what are they? The first elements when I take from the ordered pair, what do I get? It is set 1, 2, 3 as well as you have 5 also. So, set 1, 2, 3, 5. Those are the first elements from the ordered pair. Now, that set gives you the domain. That set gives you the domain. And if you look at, this is exactly same as our set A. So, either you can represent this as set 1, 2, 3, 5 or even simply you can write what? A. That gives you what? Domain. Now, coming to the range of the relation. What is range? The second element in this ordered pair. The second element in this ordered pair gives you the range. So, what are they? 4, 6 and 9. 4, 6 and 9. Set 4, 6 and 9. Now, what is this? If you look at this side, you can see that this is exactly same as what? Our set B. It is exactly same as B. Now, coming to codomain. What is codomain of this relation? Now remember children, the relation has been established from set A to set B. Set A to set B. To which set is it is defined to. To which set the relation is defined to? Which is set B. So set B, that is to which set it is defined to. That set is called as the codomain of the relation. Codomain of the relation. I hope you understood this. The concept of domain, codomain, range. Okay. You can have a quick look into this.